Recording. Good morning, good afternoon, good evening to people around the world. This is Martin Hubel, your host of the DB2Night show, as always. And today we're up to show number Z129 or Z129. I'm bilingual. I speak both Canadian and American as required. Our special guest today is Roy Boxwell from SEGAS, or Software Engineering Group, depending on what part of the world you live in. How are you doing today, Roy?
I'm doing very, very well, thank you. It's Friday evening for me, so I'm looking forward to my first beer in about 2 hours.
Yes, I appreciate you not drinking. The problem with drinking, you see, is that if you spill it, we'll hear all about it on the show, and we'd rather you wait until afterwards.
That would be a disaster.
Yeah, it's a waste of good beer. We call that alcohol abuse when I was in the Canadian Army. So let's move along. I'll get my standard things out of the way. Once again, are getting involved. Follow hashtag DB2Night, please, on Twitter. That gives you the latest and greatest in terms of when shows are coming on, who's our speaker, and also when replays become available on YouTube. In addition, we still have the standard downloads if you like to do it that way. I'm hoping Roy will be as gracious as he has been in the past and provide his PDF of his slides, because people often like to have that around. And
yep, will do, no problem.
Perfect. And so let's move on. The disclaimers is same as everything. There are trademarks out there which we respect, and we will. Everything's copyright DBI because they basically are the founding and owner of the DB2Night show. And we appreciate their support and a willingness to make this platform available to us. And replays are available later. As always, upcoming shows. Now, I do have a very good line on the shows that will be coming up for DB2 on Z. I just haven't gotten around to getting everything confirmed. The good news personally for me this week is the Central Canada DB2 user group, which is one of the larger regional user groups in the world. We had our first face-to-face meeting this week, and a lot of great speakers up from the States. Ulf Heinrich of Software Engineering Group came all the way over from Germany to speak with us as well. So we had a really good time. The facility we had was great, and everybody was so relieved and happy to be back together. Precautions were in place, and we did really well. We had a nice reception afterwards and stuff like that. So life is good. But having said that, I've got a lot of speakers that I'll be reaching out to fill the schedule through at least January, and I'll be posting those dates shortly and get them up on the website. So bear with me there. On the DB2 LUW side, we've had a lot more success. The IBM Toronto Lab has come through in so many ways for us. We have PureScale on Amazon coming up next month. That'll be interesting to see, because we're all seem to be being pushed towards the cloud and that sort of thing, and containerization. So IBM wants to deliver that message. Then we've got some things from Les King, who is the DB2 product manager. He's been around forever. He's been a past guest on the show. And on December 2nd, we have a DB2 11.5.8 with Kerry Romanoff, the DB2 chief architect. And still wondering why they can't get up to 12. They keep coming up with these sub numbers all the time.
They don't want to get confused with ZOS, probably.
Well, actually, they were ahead of you. They were on 11 before the mainframe, but they've then gone into this. No, we're not there yet. No, not yet. But next, I call it dodecaphobia, which is similar to tristidecaphobia, but this is the fear of the number 12.
Yeah. But
they say that at some point in the future there will be a 12. So we're waiting for that to happen. But it's a slam bang lineup, and we'll look forward to getting the rest of the shows up. Apologize for the little bit of a delay on the Z side as we get those announced. As again, follow hashtag DB2Night, and we'll give you the latest and greatest via Twitter and on our website, of course, where you register. As always, we have our founding sponsor, DBI Software, is a DB2 LUW performance vendor, and they have demos and new versions of their products out. And they're worth looking into if you are a DB2 LUW user that requires ways of monitoring performance reliably and that sort of thing. The products have been around for a very long time now. Our winner last month is Sanjay Trehan of Healthcare Service Corp. Actually, I consulted with them or did some contract work with them just before Y2K. It seems like just yesterday, 23 years ago. Back in the days when PeopleSoft and DB2 were things that worked together. And sponsors, just another reminder of DBI and yours truly, sponsors of the show. And here's my comic relief before I turn things over to Roy. This is the same picture I put up last month. I just mirrored it, but we've now decided that they are the Chihuahua Cartel. Sometimes we call them the Chihuahua Mafia. They're thick as thieves. And I just come in from going out shopping on a very hot day in Toronto, and they're licking my head for the moisture. It's so nice to be groomed. It really takes a getting used to, I'll tell you. And they're not particular. We have some beef snacks, which they absolutely love, and they also have some beef liver, which they also will take. But I think they're really into the beef. I think it's beef lung, but it's 100% beef, and they just love that. So, and they're just delightful. They're lovely dogs. Okay, Roy, you're up. Let me do a quick switch-o change-o here to make you the presenter. You should have a message on your screen.
Yep.
And there we see. I see everything looks marvelous.
Very good.
So as always, what I'll do is monitor the question queue, and I'll interject as needed. In the meantime, though, I'll mute my mic in case there's any background noise on this side. So please take her away.
Okay, thank you very much, Martin. It's always a pleasure being here. It's a real shame I couldn't be at the Canadian user group, but I had other private appointments in Berlin, which took precedence. So today, UTS, Universal Tablespaces, past, present, and a glimpse, perhaps, in the future. So I'm going to run through basically a history of tablespaces. Without knowing what tablespaces were, you can't really see where they are, and you probably can't think about where they're going. That then goes nicely into universal tablespaces, or UTSs. So then we have the present UTS situation. Present for this presentation is basically version 12. Yeah, we're all aware that version 13 is out there, and they've even got up to 501 already. But as far as I'm concerned, most of the customers I go to and most of the people I speak to, they're still at version 12. So the present is version 12. The future is then about version 13 and perhaps beyond. And then, as always, as Martin said, we have Q&A. But feel free to put something in the chat, and we can happily answer it as we go. So, tablespaces, a brief history. When DB2, with a capital B, was first released, it came with only two ways of actually storing data, non-partitioned and partitioned. That was it. It was really simple in those days. Excuse the pun, because of course, non-partitioned were also simple spaces. The way it works, non-partitioned, you have one page of the table space, and in that one page, you just got rows from table A, from table B, from table C, and the second row from table A. It could contain many tables, and all rows were stored anywhere within the pages where they physically fitted. Very easy to code, I can believe, but of course for performance, it was a bit of a killer. Yeah, you had to always look, where is my row within all the tables that are in the space? So it wasn't that good. And each of these VSAM datasets that were a simple space could only get to 2 gigs, which, of course, in those days, back in the 80s, was huge. Yeah, and if required, DB2 could even allocate a new one, and this could go up to 32 datasets, giving us 64 gigabytes of data. which of course was massive. Who needs more than 64 gigs? Partitioned was a little bit different, as we're all aware. Partition was basically one page of, in this example, of a partition table space. You only get the rows for a table. A partition table space only has one table. Rows are stored anywhere within the pages where they fit in their sort of predefined partition. Yeah, the partitions were done by a partitioning key, which we'll get to in a minute. This enabled extremely large tables, yeah, with up to 16 partitions. Each of the partitions could be 4 gigs, yeah, or you could only have 64 partitions, even more, but only 1 gig. But in either case, you got 64 gigs. So when DB2 started, we had this limit of 64 gigs. That was it, with partitioned and non-partitioned. And to get the partitioned, you actually needed a partitioned index as well. You probably remember creating all these. And so the index was used by DB2 to decide where that physical row was going to be inserted. Yeah, and so you had to create the partitioning index before you could even use the partitioned table space. Now, of course, this was, I say here, is an added difficulty. The real problem was always, of course, if you wanted a new partition, or, please not, you wanted to change your partitioning key. Now, we're all aware what an absolute nightmare that was, yeah, because basically you couldn't do it. Schema independence and schema modification didn't exist. The secondary problem, which not many people hit, but was there, was the size of the partitioning index, because you couldn't actually specify the size of the partitioning index. It was sort of dependent on the table space and the index space, buffer pool, or page size. Yeah, and this, of course, was pretty tricky. This meant trying to tie all these things together of how big is your partition, how big is your partitioning index, was actually very tricky. And this would not be solved, completely solved, for many, many, many years. Yeah. Indexes, this is the pendant to table spaces, of course, came in 2 types in those days: unique, non-unique. But of course, indexes, not really important, just to mention they exist. And the indexes were limited, also dependent on the size and the definition of the table space. And you were limited to a number of VSAM datasets for your non-partitioned index, what was called in those days an MPI. And you had a size for a partitioned index that only fitted, of course, being a partition in one VSAM dataset. With partitioned objects, you couldn't go to multiple datasets because the partitioning number was at the end of the physical VSAM cluster name. Yeah, so you had partition 1 was in 1, 2 was in 2, 3 was in 3, etc. So you couldn't go to 1 point second dataset. That didn't exist. That was a hard physical limit. And these numbers and sizes were very highly correlated. We'll see a bit more later, to the page size, the index page size, and even the physical possible maximum partition count of the underlying table space. Now, I don't mean here the number of partitions you've got defined. I mean the maximum physical number of partitions that you could define. This is something which is very important when you're trying to work out how big things are. You might have defined 8 partitions, and so you'd work out the calculation. You'll get it wrong, because what you actually have to do is work out, for this data set with this buffer pool page, I could have 2048 partitions, and that number must be used for working out the space of your index. Not exactly easy. Then along in DB2 2.1, the first, what I call like big change for space management happened, and that was the segmented, non-partitioned table space. This was a groundbreaking idea, and still exists to this day, and we all use it because it's simply very efficient. You have in your table space, you have table A, table B, table C. The rows are no longer mixed. Within a segment within a table space, you only and are guaranteed to have the rows of one table. This, of course, meant the processing could be much more efficient. It wouldn't have to say which table U, which table U, which table U. It knew in that segment table A, and it's done. Yeah, your segment size could be from 4 to 64 pages. Most people said it to 64. Quite why 4 pages is there, I've never really worked out. And what it really did is it speeded up mass delete and insert dramatically. Yeah, you were still limited to 32 VSAM datasets, but now we had this new tool in our bag, yeah, of going segmented. Then along came a few versions of DB2 that didn't do much for table space. We had things like data sharing and stuff, but that didn't actually change space definitions. So in DB2 V9, partition spaces got a pretty good upgrade with the member cluster keyword and the large syntax. This allowed you to go to 254 partitions, each of which could be 4 gigs, giving you 1,000 gigs as a maximum size. And the member cluster was very good for doing mass inserts across members of a data sharing group. Then in 6.1, partition spaces got another upgrade, another major upgrade, this time with the DS size. Yeah? And at this point, IBM decided that the large clause could now disappear. So DB261, the large clause, was deprecated because at this point, everything that we're creating that is going to be big should be using the DS size. And the DS size enabled, again, 254 partitions, but each of them could now be up to 64 gigs, each partition, not the complete system. And that gave you 16 terabytes, which, of course, was a quantum leap. Yeah. Now, to get to this size, you had to make sure your SMS guys were on board because you needed the XX. You needed the extended format and the extended addressability. Now, I've been to shops where that is still not the case. So you really want to make sure that you have those switched on. Otherwise, you are really limited to 4 gig, which you might not think is a problem. But of course, with the amount of data we're getting these days, it probably will be a problem. Then in DB2.8, the DB2.8, that's well known as the biggest ever. I think one of the things which I remember from 8 was there were more lines of change code in DB2 version 8 than in DB2 1.3. Yeah, this is when everything got large. You remember, everything went from 8 bytes to 128 bytes or 18 bytes to 128 bytes, index names. Everything got changed. And what they also did was they enabled you to go to 4,096 partitions. Of course, this is crazy size, which enables you, as I show here, to get up to 128 terabytes. Now, it might sound good, but that number isn't as high as you would think, yeah? Because we've seen what you have with 64 partitions and 254 partitions, and at 4,096, you would assume a lot more than 128. But you have to pay the ferryman. They still had a major problem with the page size and the partition number and the RID. This was going to be a problem that would take them, again, years to solve, yeah? And at this point in time, because of these massive partitioned objects, people started getting problems with NPIs, because with an NPI, it could go to multiple data sets, but in NPI terms, they're called pieces. But to work out how many pieces you could have was, again, a very difficult set of calculations. It's not easy. In fact, companies have written software to warn you when you're hitting these limits. And so what they also then did, they said, we got another bonus here. We got this problem with the MPIs, but what we'll do is we'll get rid of the partitioning index. In version 8, you might well remember, you did not need a partitioning index anymore for a partitioning object. They called it table-based partitioning. And simply put, the definition that you used to use for the index is embedded in the table. Yeah? Why do you need it in both places anyway? And so then IBM said, then we can get rid of that partitioning index. If you're only using the partitioning index to partition the data and not for, say, data access, then you didn't even need to create it anymore. Or if it already existed, you could drop it. Yeah? Then came a small problem. This introduced the DIPSI, the Data Partitioned Secondary Index. Now, this little baby is still causing DBAs and consultants grief to this day. Because when people create DIPSIs, most people don't think about it. Sometimes they don't even know they've created a DIPSI, and everything seems to work until it doesn't. Yeah, so DIPSIs are a problem that you have to understand exactly. What is a DIPSI? Do you need a DIPSI? It's not as simple as it used to be. And they chose to rename our beloved NPI to a NIPSI. Now, might sound funny, but I still call them NPIs. I cannot call them NIPSIs. I can't keep a straight face for that. That's a brief history of tablespaces, what we've had right up until version 8. And then we have universal tablespaces. Now, universal tablespaces came out in version 9, brand new. We call them UTSs from now on. And you have to think of it as a cross between a segmented tablespace and a partitioned tablespace. It gives us, because it's got a space map and stuff, and it's segmented, it gives you the benefit of mass delete, gives us the benefit of the inserting, like it is with segmented. And it gave us the ability to get ridiculously big. You could go totally crazy with these things. When it came out of the box, it was delivered in 2 flavors: partition by growth, which you can imagine is just a container that you throw data into, and partition by range, which was pretty obviously a replacement for the existing partitioning by table, or even in older partitioning by index table spaces. And the idea was, of course, that we as users and DB2 users should migrate to these universal table spaces. Now, PBGs cause grief right from the get-go. I remember a whole bunch of people saying, this is great. I'll just create my container with max partitions 4096, and I'll never have to touch it again. This, of course, was a disaster. And I've got a quote in here from IBM. You can happily read it. The problem was memory. That even if you haven't allocated these 4096 partitions, it needs control blocks for them in case they get allocated. We might think this is crazy, but it's the way it was designed. It's the way it worked. So everyone came out with these max partitions 4096, then found out it was a complete disaster. And then, of course, came the fun that you couldn't alter the max partitions to be lower than the version that you had. There was a lot of fun. There were lots of APARs and various alter fixes. But basically, don't ever do this. PBRs, on the other hand, were fantastic. Migrating to them, of course, was a bit of a pain. We are all aware when you're migrating a table space, by definition, you've got to reorg at the table space. Or even worse, you've got to drop, unload, drop, recreate, reload, which is nightmare. But once you get to a PBR, you're in a happier place. And so PBRs are indeed very, very nice. And we actually see that the migration got worse over time, which is quite scary. And UTS is super, because IBM development has mentioned on multiple occasions that any new DB2 features are only going to be for these babies. So clone spaces, hash spaces, currently committed, pending, inline lobs, which are fantastic. If you've got lobs, inline lobs is just simply brilliant for performance, XML multi-versioning, and even the alter table drop column. There's a bunch of other stuff I haven't bothered listing, but basically all new development is just for UTS. They're not doing anything with simple or segmented or classic partitioned anymore. So we have to migrate our way through to get to these 2 things. The maximum size was dependent on whether you had large or not on the creation, whether you used the S size or not on the creation, and whether there were more than 254 partitions on the create table space DDL. And so here you can see your maximum partition size calculation with numparts up to 254. And you can see it oscillates between 421 and 4 gigs. It's not that clear, but it's the way it is. And this is your maximum physical partition size. If you try and do an insert beyond that size, you get a -904 and your application dies. And it gets more complex when the number of partitions was more than 254, because then the dependency wasn't on the parts, it was then on the page size. So then your page size had a direct impact on your maximum partition size. And if you specified the DS size by create, then your maximum number of partitions was physically constrained. This is complex. This is not really what you need, but it's the way it was when it came out in version 9. In version 10, partition spaces got another upgrade. This time the DS size keyword got expanded, so we could actually then go up to 128 gigs or even 256 gigs per partition, remember? And for PBGs, due to this tie-in with page size and the max partitions, the maximum size stayed at 128 terabytes. They didn't grow in version 10. And for PBRs, again, the maximum size depended and depends on how many partitions there are defined and their physical page size. This harks back to the very first defining and definitions of partition spaces. This is still a problem, right up to version 10. And so then I've got a few examples here. I won't bore you with reading them, but basically you can see, depending on page size and DS size, that affected your num parts, which directly affected the maximum size of your table space. And this was very confusing. I don't know anyone who knows all of this in their head. You always have to get all the manuals out, read through the documentation and stuff, and it takes forever to try and find this all out. All in all, extremely confusing, and it used to, and it still does, drive me nuts. So what else as problems were there? Well, the problem is changing a single partitioning or a partitioning index isn't possible because it was one size fits all. Yeah, you have to change all partitions and do a table space or index level reorg to apply that change, which if you only got a hotspot of one partition is really annoying, but it's the way it was. The insert space map processing in PBGs is a complete disaster as the number of partition grows. It is really quite impressively bad. And it gets even worse if you're unfortunate enough to have descending key columns, because then the way the insert works is sometimes quasi-random. John Campbell mentioned this, and he wanted this thing removed, this feature, but I don't think he managed it before he retired. And what basically happens is the inserts then go backwards from your max partitions. And that means you get empty partitions if you're unlucky. But you think they're full because it's descending insert. They've improved it in DB2 There's a red book, chapter 4.3.2, where they explain this insert processing is better in DB2 but it's still there as a problem. And of course, utility parallelism with PBGs doesn't exist. You have one huge space. You can't reorg part one of a PBG. Just with part two, it doesn't work. It's just because it says, no, this is one space. And the other major problem is the links between large, DS size, num parts, and page size. All these tables and all these rules that you just have to know. And remember, it's the maximum number of parts that you have, not the actual number of parts that you have, that is really important. And so you have to trawl through all the books again and again and again. In DB211, IBM then decided, okay, we're going to kill everything that's not UTS. So in DB211, all non-universal table spaces got deprecated. So from this point on, only UTS should be used. Now you have to remember, this is all done through Apple Compat, and you can change your spoofy or your DDL program choice, step 2, step 4, whatever, to have any application compatibility level you like, to then create any table space type that you like. So what this means is default for a new installation, you can't create anything, but you can always still do it. IBM are always worried, of course, about recovery. So if you've got an old space that you haven't yet migrated and you have to do some sort of recreate recovery work, you have to be able to recreate that old space. That's why even in DB2 13.501, you can still create segmented spaces. You shouldn't really be doing it, but you can. And at this point in DB211, IBM, and you should never say IBM, but it was actually John Campbell and a whole bunch of others, started recommending use lower numbers of max partitions with PBG because of this space map issue, because of the descending key issue, and because of the memory issue. So this was all in DB211. That's recap where we are with universals. Now we're going to have a quick look at the present. And the present for me, as I mentioned at the beginning of the presentation, is version 12. So in version 12, another new table space appeared. This time it's the UTS PBR relative page number, or RPN. And of course, this is fantastic. It's a TLA, TLA, TLA. It's a UTS PBR RPN, which is wonderful. But being serious, this, in fact, for me, was the single best thing in DB212. Because what this did is the first bits of the 5-byte RID for all your spaces, partition spaces, contains the partition number. And as this partitioning number got bigger and bigger, the number of bits available to point to a page number shrunk down. Hence the massive number of tables describing the limits, because it was all about bits and bytes, really just about bits. And so what they did in DB212 with this brand new space is they changed all this. The RID byte went to the RID bits, the RID size went to 7 bytes. And of course, 7 bytes is fantastic. This completely decoupled anything to do with the partition number, page size, and DS size. And I've got a link here. Oh, there's a question?
No, actually, there's an idiot on the other end of this thing because I forgot to do the polls today.
Ah!
I'm just sitting here going, we could launch them right now. So if you want to just give me half a minute, we'll get a little more information in here.
Yeah, sure. Let's do it. Yeah.
Yeah. Well, It's just amazing to me how many different things I can get wrong on this show. There's so many little moving parts, and so there you go. Okay. We've got a lot of the audience voting, which is actually really refreshing, because when you think about it, it means that people have been on the call and are paying attention. 83% of the people participated in the poll, so that's really good news. And you see we have most people are on version 12. We've got and very little on version 11, which is refreshing and good to hear that. And the other thing we were going to ask them is, how are they doing on the conversion to UTSs? Because we know the people that are have been using DB2 for a long time sometimes are the slowest to do anything, because they're just so busy, and they rely on it so heavily. It's hard for them to get that plan done to get everything done. So let's have a look here at what we have, and I'll close that off and share the results there. 64% of the people feel they're in the process, which is hardly surprising, and there's a couple have not started, and some are on one is completely done. Great.
Hey, well done.
Indeed. Or the other thing, though, is sometimes I'm assuming that they're telling the truth, but I've been in situations where people just make stuff up and click the wrong button. I
would never do that.
I remember being on an airplane in 1997, and this particular airline. I was reading the magazine, and there was the head of the company saying, "We're one of the first airlines in the world to be Y2K compliant." And later on that trip, I actually had the opportunity to visit with the people, and they said, "We aren't doing anything because we're so busy with worrying about Y2K." And I said, "According to your magazine, you're completely done." And he says, "Don't believe everything you read." It was a real telling thing. So let me just share the results of that last one. Relative to page numbers, not in use in 62% of our audience today, and 15% are doing it, and 23% don't know. So with that, thanks folks for participating. I will stop asking questions, and we'll put things back to Roy.
Okay, so I'm back on now, yeah?
Yes, you are. And sorry to interrupt you abruptly, so it might take you.
No, that's okay. That's no problem. But yeah, I'm sending the PDF at the end of the presentation to Martin anyway, and on there's a clickable link where Hook and Roberts wrote all about PBR RPN in great detail on the IDOG website, which I can recommend having a quick read. What they also did, this of course was very, 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 very good. And this is basically the jewel in the crown of DB212, is they took the attributes of a PBR and extended them down to the partition level. Yeah, and this is the big win. You have the ability to then allocate each and every partition size independent of the other one. And you can go from 1 gig to 1024 gigs using any value you like. No more binary steps, no more strange numbers, apart from you might choose 117 gigs for a partitioning index and 123 gigs for the partition. It doesn't matter. You can do this for each partition and each partition index, which is fantastic. But that alone isn't really brilliant. What is really, really good is that you could alter these on the fly even when a load is running and it works. I have tested this multiple times, and I'm not working for IBM. When you're running a load, doing like an SAP transport or just doing a massive load, and you start running out of space in a partition, you can just alter it, add 5 gigs, and it carries on. No outage, no rerunning, no worries. It is really, really good. Same is true for indexes, yeah? And of course, they can have different sizes, which is probably not that interesting, but it gives you the ability to mix and match and to vary your hotspots and your data. And this is simply fantastic. This was, for me, brilliant. Now, there's no such thing as a free lunch, yeah? And of course, the problem was if you wanted to reduce the size, because you can't do that. If you want to reduce the size, of course, the problem is when you have an object with, say, 7 gigs, and you say, I want to reduce it to 3, DB2 is stuck in a bad place, yeah? It goes, I don't know how big that object is. I can't just cap it at 3 gigs. There might be data in it to say 4, I don't know, or maybe just 1 byte over 3 gigs. It doesn't matter. And so the moment you do that, that of course is a pending DDL, which has to be externalized with a reorg. Yeah. But on the other hand, and the way I look upon this is whose data shrinks. I don't know anyone, apart from those using archive tables, whatever, where the data shrinks in size. Nearly everybody's data is growing in size. Now, the real problem, this was an absolute hammer problem, killer, really, the migration. Going from a UTS PBR to a UTS PBR RPN requires, because of course, think about it, you're changing the RID size from 5 bytes to 7 bytes. You cannot do that at the partition level. It's not going to fly. So you have to do a tablespace level reorg with TP level inline image copies. Now, of course, the worst case is you got 4,096 partitions. You have to allocate 4,096 data sets in parallel. And of course, it's a UTS PBR, so they're probably big. And so you got to put them to tape. No one's got that many units. And so it's not going to happen. And of course, it didn't. No one used it for migration. People are using this or used it straight away for new spaces because then, of course, it was from the get-go. It was okay. But for migration, it was terrible. And then lots of people opened AHA requests or APARs or whatever you want to call it. And then after a few years, IBM then came out with this fix, the IC limit underscore tape or the IC limit underscore DASD, which you can use in the reorg utility. And of course, this is really cool. And I've tested this as well. And so the idea is that you can say, I want up to 50 data sets on this tape. And so then you can really break down your tablespace reorg into chunks which fit into your VTS. Yeah, they did it for DASD as well. I must admit, I don't know why. It might have been just to be compatible. Of course, for DASD, that makes no real sense. But for tape, that's where the win is. And so finally, you have, with the relevant APARs, the ability to migrate relatively seamlessly from PBR to PBR RPN. And this is where we should all be going. We should all be running down the road as fast as we can to get to UTS PBR RPN. Forget everything else. Forget PBG. Get to UTS PBR RPN because that's where the future is. And so the official recommendations all around UTS changed again. PBGs, believe it or not, the official recommendation now is max partitions 1 with a DS size of 64 gigs. Now, I'll do another presentation every now and again on a customer site. It's all about DB2 limits. And you might remember at the very beginning of this presentation, 64 gigs was the limit that we used to have, yeah, with simple and segmented spaces. We had 2 gigs for the data set and you had 32 of them. So right now with DB212, we're back to where we were with DB2 1.3. Okay, it's a single data set, but it's still only 64 gigs because they absolutely hate the multi-partitions. And the other problem with PBGs is when you alter the number of partitions, it's a painful process, yeah, because for reasons unbeknownst to me, and I have opened APARs, I chatted with Terry Purcell when he was with IBM, I've done AHAs. The real problem for me is I cannot understand why increasing the number of partitions in max partitions invalidates all of the packages, static packages, that access or use that table space. I cannot understand that for the love of money. They first responded to it, said, yeah, it's because of parallel access. Said, there is no parallel access of a PBG. It's one huge table space. There can't be parallel access. So I don't know why it's there. And I said to them, I said, we could compromise that you could change the max partitions up to, say, 256 without causing a rebind of all the packages. But no, it's been rejected. And so now, anyway, the recommendation is max partitions 1, DS size 64, and we're all happy. And for PBR, obviously, use the PBR relative, the RPN. and migrate any of your current PBRs to the new one. So this, of course, was a bit of work, putting it mildly. It's nice that in the questions, a couple of people have actually started it or even completed the migration to all these things. In DB212 FL508, they brought out a new alter tablespace move table syntax. Yeah, and this is trying to push us down the road of just getting away from simple and segmented. Yeah, because this takes us from the simple and segmented tablespace world to PBG spaces. The problem with this, in a nutshell, is QMF. QMF is the 500 kilo gorilla sat in the corner of the room going, I've got one tablespace with 6,000 tables in it. What are you going to do? Yeah, and so QMF is the problem here. Most normal applications don't have that many tables in a tablespace, but QMF, of course, does. And so if you have a lot of production users saving data away, it could be a challenge. Yeah. And so there's a wonderful bit of documentation here. Again, it's a link in the PDF, just taking you off how to actually do this, how to use it, how to set it up. If you go to the AHA ideas, there are a couple of ideas about improving the way this works, especially with implicit table spaces, because the way it works is you actually have to predefine the table spaces as defined no. And it would be much nicer if DB2 did all the heavy lifting. Yeah, you just say, alter table space, move table, and just take everything and do everything. Nobody these days, in my humble opinion, should care about the name of the table space. That should no longer be an issue. And so an implicit table space name, for me, is no longer a no-no. Many, many years ago, with like micro and macro management, you had to know the first 3 characters of your table space or whatever for reorgs, copies, run stats. I would hope that in most shops, those days are gone. Yeah, that you should just be looking at it as a table or as an application, no longer actually at the table space level. Yeah, and so there's an AHA idea. I think it needs a few more votes. So now we have the future. Where's it all going? Yeah. Well, in DB213, of course, one of the big things that came in there was the ability to convert from PBG to PBR. And again, just cut and pasted from the IBM documentation. You don't have to believe me. I don't know everything. And here it's got, they are these strategic table spaces, but if an existing table grows too large, performance degradation of data and index management issues might arise. That's IBM speak for, we have a massive problem with doing inserts. Yeah. It's, I think suboptimal is the right word. Consider converting from PBG to PBR. This is a nice way of saying, yeah, do it. Don't just consider it. You really should start planning on doing this, yeah? PBG to PBR. And it sounds a bit strange, but it's actually relatively easy to do. You just have this command. It's an alter table command. The trouble is, of course, you have to have a key. You have to have a key that you can partition on. And this is another AHA idea you can go looking for, where people are saying we want to use the hidden row ID, for example, as a partitioning key. But a lot of data does have partitioning keys. The trick is to get your data scientists on board to actually find them. Yeah, and then you just issue this, you have a reorg, and then tra-la, as if by magic, your PBG has now auto-magically gone across into a PBR RPN space. I won't bore you with the horrible details. I've got another link in here from the IBM documentation which tells you how to do it, what DS sizes are used, and blah, blah, blah. Yeah, it's all very standard stuff. It's not that difficult. The trick is, as I mentioned, you got to get a partitioning key. And again, no free lunch. There's always something causing trouble. There's no XML support for this. Yeah? If you have XML columns, you can't do it. There's no lob support, which I find really quite sad. If your table is in a clone relationship, but no one really I am aware of is using clones anymore. Lots of people clone data. Yeah, you clone your data from production to test with hashing or randomization or whatever, but using a clone table, these days most people just use these share level change load, like mass insert. So you don't really need a clone space anymore. And not a hash table, but no one should be using hash tables anyway because they've been deprecated, and the parrot has now definitely died on hash tables. It was a nice idea, but it died. And in the AHA system, and here I've actually even got the AHA number for you, a whole bunch of people are saying we need lobs because a lot of people use lobs and a lot of people use inline lobs, and it would be so cool if you could migrate automatically also with lobs. XMLs, yeah, nice to have. I haven't seen many people actually using them like that. But as I mentioned, the lobs would be really, really cool. Whoop. And so as of, hang on, I think I've gone back too far. Yeah, so as of now, DB213, you can define a UTS PBR RPN with a DS size of 1024 gigs. This gives you a maximum table size of 4 petabytes, which can contain over 280 trillion rows of data. But even this is not actually the end. Yeah, this is where I'm looking in the crystal ball. I mean, I'm not an IBM developer. I have no idea if what I'm about to say is even going to happen. But if you look into the internal definitions of everything that IBM have got, they've left themselves a little bit of what I call wiggle room. And it's not really wiggle. It's more like dancing a rumba. If you look at this, most of the fields, if not all, that hold the number of 4K pages, remember in all of the tables, in all of the if kids everywhere, everything is reduced to a 4K page. Yeah, it never records the number of Ks because we're going back to CI size and the original 4K buffer pools and stuff. Yeah, so everything is internally in numbers of 4K pages, and these are all 4-byte full words. Yeah, and up until now in DB213, the highest value used is that. That leaves a lot of 4K pages going begging. Yeah. Now, of course, with the PBR RPN, as I mentioned earlier, they've given us a 7-byte RID. This, as I said, has given us a 2-byte partition number. Now, even if they say they want to use a signed half word, that gives you 32,767 possible partitions, which is a little bit more than the 4,096 we have now, yeah? That is pretty impressive. Now, of course, I have no idea if these future things will ever actually be done, but I believe that we're not really going to run out of space in my lifetime with DB2, at least with PBR RPNs. The big problem, as far as I'm concerned, is the OBID, because the OBID is just a 2-byte hex value for the number of objects that you have. That, I think, is going to be a major problem, not the actual number of pages or whatever you have. And with that little look into the possible future, I have finished. Martin, you may take control.
What does this button do? There we are. We're back on.
Yay.
Well, that was a great summary there. Appreciate that presentation. The number of times I go into shops and stuff like that with this stuff, I've got at least one question here. Let me just see what's going on here. Oops. Sorry, the question panel is nerfed. Okay. Why is RPN such a big deal? One person is asking. I think maybe you've you talked about it.
Yeah, I hope I answered that, but it's just because it gives you the ability to change things on the fly without doing a reorg, without invalidating packages, without causing an outage, instantly. It's just fantastic.
Yeah, great. Okay, that's where we all need to be. Now, the next thing to do is for me to take back control, I guess. Let me do that. Where's this? What does this button do? I once heard that on a plane. It was not comforting. Okay, there, I'm back in charge, and after all that, I need to launch this poll here. Poll is now open. Did you learn anything today? We're getting people voting on that, and things are moving along quite nicely. So I'm going to close that off and share that result, which is 100% of our audience learned some today.
Yay!
Hey, and we're finished.
That's good. It's always good. I mean, there's something I always say. I mean, when I went to IDUG at Boston, I learned so much. When I'm going to the IDUG in Edinburgh, I learn. I might be doing DB2 now for getting on 35 years, but I still learn. It's really amazing. You never stop learning.
I've been doing DB2 now for just 37 years.
Yeah.
And the one thing that's kept me amused about it, and the thing I've always said about it, is that there's always more to learn.
Yeah, it's really quite scary. One thing which I can just tell you, which is amazing, is a colleague of mine had an SQL that was strange. The access wasn't that good. So I took it in Spoofy, explained it, and got a completely different access path than they had. I thought that can't be. We're running against the same DB2. No statistics have changed. The only difference was it was a nested table expression, and in one of the selects of a union all, there was in the select line. When I explained it, I used a working storage, so it was a host variable, and when they explained it, it had a current date.
Yes.
And if you look, it took me ages to find, but if you actually look at the documentation under managing performance, managing access with explains, checking for data, materialization, scroll right down to the bottom to note number 2, it tells you if you are using nested table expressions and you have in one of the legs a host variable, then DB2 will materialize the result of that leg.
Oh.
And I thought, I have no idea why DB2 does that, but it's something I learned today.
Yep, there's always something. So, as always, thanks to you, Roy, and to Software Engineering for coming on the show again. We love having you guys on because your topics are pointed towards tips and helping people. And we look forward to the next opportunity to have you back. And with that, I'm going to cue the music. Wish you a great weekend and our audience a great weekend. Thank you again, and we'll see you next time on the DB2Night show on October the 7th for our next LUW show. And the following week will be the C show, simply because we will be off in Edinburgh after that. So we wanted to get both shows out of the month done before that. So take good care. We'll see you next time on the DB2Night show.
Thank you very much. Bye.
That's all.